In this video today, we're going to talk about the difference between empirical and molecular formulas of a substance. So a molecular formula is just a list of what elements are in the compound and how many atoms of each of those elements are in the compound. When we see the word empirical, that's a simplified or reduced version of a molecule. So let's look at, sorry guys. So let's look at some examples. So I would call all of these molecular formulas, right? These are actually how many atoms are in the substance. If they ask you then to give an empirical formula, what you want to do is you want to look at the subscripts and see if you can divide them all by a number to make them simpler. So if I look at 6, 12, and 6, right away I see that if I divide all of those numbers by 6, I can make them smaller. So if I divide 6 by 6, I get 1, and we don't have to ever write a 1. 12 divided by 6 is 2, and 6 divided by 6 is 1. So that would be the empirical formula of that substance. All right, I want you guys to actually try the second one. Okay, and you should have gotten NO2. Now for this one, my subscripts are a 1 and a 2. I can't make them any simpler. So the empirical formula is going to actually end up being the same as the molecular formula. And that happens sometimes. Sometimes the atoms are already bonded in their simplest ratio. And that would be an example of a molecule that has the same molecular and empirical formula. All right. So, how do we find the empirical formula of a substance? Aside from being given its actual molecular formula and simplifying, you can also be given the percentages of each element in a compound. And from there, you can actually determine what the empirical formula is. So the first important rule is that you just have to assume you have 100 grams of a substance. You have to make that assumption for these types of questions. Okay. So for this question, they're telling me I have 25% H and 75% C. So I'm going to write out what my elements are. And if I'm assuming that I have 100 grams of the substance, if 25% of them are hydrogen, that means I have 25 grams of hydrogen and 75 grams of carbon. Okay. All right. Now, the subscripts in a compound, those little numbers, those stand for moles of atoms. So like in carbon dioxide, for example, if I have 1 mole of carbon dioxide, I have 2 moles of oxygen atoms in that sample. That's what those numbers stand for. So if you want to get those little numbers, you have to take these grams and you have to convert them to moles. So how am I going to do that? I know that 1 mole of every substance is equal to its mass on the periodic table. So hydrogen has a mass of 1. Grams cancel out, and I get 25 moles. I'm going to do the same thing with carbon. If I have 1 mole of carbon, I know that that's equal to 12 grams. My grams are going to cancel out, and I get 6.25 moles. Okay. Now your next step is to look at your moles, and whatever the smaller one is, the smaller number of moles, you want to divide everything else by that number. So 6.25 is smaller than 25. So I'm going to take the 6.25 and I'm going to divide it. That gives me 4 here, and that gives me 1 here. So this is telling you the ratio of carbon atoms to hydrogen atoms in this compound. So the empirical formula would be 1C and 4 H's. All right. Let's do the next one. This one's a little bit more tricky. So I have nitrogen and oxygen. If I'm assuming we have 100 grams of the sample, then these percents can be my number of grams. To get rid of grams and get moles, I want to look up their masses on the periodic table. Nitrogen is 14. Oxygen is 16. All right, grams cancels out. Now, if you guys go ahead and put this in your calculator, you should get 1.85 moles here and 4.63 moles here. And if you divide both by 1.85, because that's your smaller number, you're going to get 1 and 2.5. Now, guys, your subscripts have to be whole numbers. So now in the example above this, you might not get exactly the number 4 in your calculator when you divide, but if you get 3.99989, that's close enough to round it up to 4. Same thing with getting 1 as your answer. You might have gotten 1.000152, something like that, but there were a whole bunch of zeros that followed the decimal place. So to round it to 1 is pretty safe. If you don't have a number that's that close to being the whole number itself, then you can't just like round it to whatever it's closer to. So what you want to do here to make that number a whole number, if you just double everything, if I times this by 2, this becomes 2. And if I times this by 2, this becomes a 5. Okay, so you just want to multiply it by something that makes it a whole number. And if you multiply one of the elements, you have to multiply all of them. All right, so now I know my ratio of nitrogen to oxygen is 2 to 5. So my empirical formula will be N2O5. All right. And then, guys, our last formula for today is finding the molecular formula of a substance. So now they're giving you the simplified version, and they want to know what the real molecule actually has in it. Okay, so just given the empirical formula, there's an infinite number of possibilities. I can double this, I can triple it, I could quadruple it, I can times each element by 30. There are an infinite number of molecules that can simplify down to CH2O. So to find the molecular formula, they can't only give you that, they also have to tell you how much the molecule itself weighs when it's in its full version. Okay, so my first step here is to find the mass of the empirical formula. So carbon is 12, 2 hydrogens is 2, oxygen is 16. When I add that up, well, I get 30. Now you want to say, okay, how many of these little empirical formulas fit into my whole molecule? So I want to divide. I want to see how many times does 30 go into 90? And I get 3. So guys, what that's telling me now is that the real molecule is actually 3 times bigger than its simplified version. So my last step is to multiply that 3 by all the subscripts that are in the empirical version. So instead of having 1C, I'm going to have 3. Instead of 2 H's, I'm going to have 6. And instead of 1 O, I'm going to have 3. And that's my molecular formula. 2 ways to check this over, guys. Does 3, 6, and 3 simplify to 1, 2, 1? Yes, but a lot of things simplify to 1, 2, 1. So the next thing you can do is you can actually say, all right, well, 3 carbons is 48, 36. Sorry. 12 plus 12 plus 12 is 36. 6 hydrogens weigh 6. 3 oxygens weigh 48. If I add this all up, what do I get? I get 90, which is what I'm supposed to get. So that's a nice way you can check. All right. All right, guys. Couple practice questions. We're going to get into like tying this all up in the next couple videos. And I'll see you guys tomorrow. Have a good day.